Welcome to another lesson of Transparent Physics. This one's on basic unit conversion, and we will have a follow-up lesson to give some more advanced applications. When we're talking about unit conversion, basically it means taking one measurement that has a certain unit and converting it to an equivalent value in another unit, say seconds to hours or meters to kilometers, things like that. Unit conversion sometimes goes by different names. When I learned it in high school, we referred to it as the factor label method. You may also see it listed as dimensional analysis. These are all the same thing. We're just looking to take one unit and convert it to another one. So let's have a nice sip of tea. No reason to be stressed out at all. Oh no, it's a pop quiz. All right, so let's get some questions here first, and we'll see how you do. Question number one. Okay, hopefully you take a look at this and you recognize that it is going to be, we've got an initial measurement. A measurement has a number and a unit, and we're multiplying it by the quantity 4 over 4. Now, since 4 over 4, the value on the top equals the value on the bottom, this is effectively equal to 1. And anything times 1 is just itself again. So 35 centimeters times 1 is just going to be 35 centimeters again. So that's an easy one. Okay, level 2 question. Okay, so again, now this fraction doesn't look the same on the top and the bottom, but if we analyze it, we see that 2 plus 6 is 8, 12 minus 4 is 8. So actually, even though the top and the bottom of the fraction look different, they are the same value. Since they're the same value, it's basically equal to 1 again. So 35 times 1 gets you 35 again. So not too bad. And the final question in our quiz. So we may know that 100 centimeters is the same as 1 meter. These are equivalent to each other. So you would be tempted to say, well, the value on the top is equal to the value on the bottom. So it's 1. So 35 times 1 just gets you 35 again. And while that logic is sound, when we have it set up like this is actually a unit conversion. So we're not going to end up with centimeters at the end, we're going to end up with meters, and if we do that, it's actually going to be 35 divided by 100, which is going to get us 0.35 meters. Now, we're not actually cheating in the idea that multiplying by 1 does not change the value of the measurement. What's important to realize here is even though this looks different, it is the same value. So effectively, we did kind of multiply by 1 because we're not changing the value of the measurement. 35 centimeters is exactly the same as 0.35. And that's really what I want to try to emphasize today during this lesson. We are not changing the value of the measurement. We are simply changing the unit, the scale of the unit, however you want to think about it. So it's going to look different. But if I was to order a 35 centimeter, I don't know, sandwich, and I was to order a 0.35 meter sandwich, assuming that it's the same sandwich, I would get the same sandwich either way. Effectively, I have changed the way the measurement looks, but I haven't changed the value. So if we remember that moving forward, we are going to be golden. Okay, so let's talk about how we actually get this done. Now, I personally would argue that this kind of stuff, I have to imagine a lot of the viewers have seen this before. At least in the American education system, I teach high school physics, which is towards the end of the spectrum, and I know for a fact that we've taught unit conversion in middle school. They've gotten it definitely in chemistry. So, but I still find myself reteaching it a lot at the later high school stages. And I think a lot of it is associated with the quote I have right here. And again, there's a lot of variations of that. But the argument is that we can teach you how to convert units all we want to, but you really have to learn what you're doing in order to remember it. I tell the kids it's much easier to remember on a test things that you understand as opposed to things you just memorized. So let's talk about what unit conversion actually is. Let's understand what it's all about, and then hopefully you'll have a better sense of how it works, and you'll remember how to do it, and you'll never have to watch this video again. Not that I would mind. I mean, feel free to tune in again just for the memories. And so there we are. Again, let's make sure we understand the process so we can increase our retention. So in order to convert units, I have what we call the unit conversion two-step. And it's a little dance you can do to make sure you are always converting units properly. And the first thing we need to do is we need to set up a fraction that is equal to 1. Now, that's similar to what we did right here. This is a fraction that is equal to 1. The value on the top is equal to the value on the bottom. Now, this is going to require maybe a little bit of additional information. You might need to look it up in your textbook or online or something like that. But however you set it up, the value on the top must equal the value on the bottom. And generally speaking, when you set up your fractions, one of the values should be related to the measurement you're starting with, or that you're at that point in the conversion. The other one should relate to getting you closer to your goal. And I'll show you what that means in a minute. So it's not just any fraction in the universe. It has a specific role in getting you one step closer or completing the conversion. And again, the values, some of them you'll know. If I was to say how many centimeters are in a meter, hopefully you'd have a sense of that. More complicated ones you might have to look up. You won't necessarily know all the values, but it's important that the value on the top and the value on the bottom are equal to each other. Once you have that done, you're going to orient your fraction such that it cancels with a unit you have in your original value, at least somewhere earlier in the calculation. And we might flip our fraction to make that happen. It doesn't change the value of a fraction to flip it. If I write 2.54 centimeters over 1 inch, that is the same as saying 1 inch over 2.54 centimeters. It's the same value. Flipping it doesn't change that at all. And factoring means different things in different parts of math. But one of the things in terms of factoring is getting, like, pulling a term out so it cancels on the top and the bottom, kind of like least common denominator stuff. And that's sort of how I think about it. We're canceling out diagonally top and bottom. I'm assuming that's where the term factor label came from. So let's take a look at a couple of these steps. But it's just a two-step process all the time. We have to make sure our fraction is equal to 1 and make sure we're canceling stuff out when we do it. If you get those two things squared away, you're going to work your way to an answer. It may not be in one step, but you will get there. Okay. Slide my T over, make a little more room, and let's take a look at our first sample question. All right, there we go. Doesn't quite fit in. All right, so as to not zoom too far out, we'll take a look at this and we'll go from there. So the first example, Sandra Allen was recognized as the world's tallest woman at 7 foot 7 inches. 7 foot 7 inches is also 91 inches. Okay, so there we go. We'll fit it all on the screen there. So we're interested in her height in centimeters. So when we set this up, there's a couple cosmetic choices you can make too. I'm going to use what I call the multiplication technique for this one. Again, it's the exact same process. It just looks a little bit differently. So what we're going to do is we're going to start with the information we have. Rearrange myself a little bit. Okay. So we have 91 inches. And we're going to set up a fraction that's equal to 1. Now, I already have the conversion here. If you didn't happen to know that there's 2.54 centimeters in an inch, or that there's 0.39 inches in a centimeter, you can look those up, maybe in your textbook or online. Usually easy to find those pieces of information. And what I'm going to do is I'm going to set up a fraction. And I am interested in, now that I have values that are related to each other, I want to set up a fraction such that inches cancels out. In order for inches to cancel out, I want inches to be on the bottom. So I could set it up like this. I could take this information right here, and I could write this. And what I have here is I have inches and inches, and the inches kind of cancel out. And then I am left with centimeters. So that is ready to solve. It doesn't have to look like that. You could have chosen the other relationship between inches and centimeters. So you could have 91 inches, and maybe I want to use this guy instead. Now, if I'm using this guy again, I still need inches on the bottom and centimeters on the top. So again, there's inches, and they cancel out, and they leave me with centimeters. And now we're going to do that calculation, if I can get my calculator handy. All right, so we're going to say, in order to do this, we're going to, for the first one, whenever we have this set up, if the number's on the bottom, we divide. If the number's on the top, we multiply. So this first guy is going to be 91. You can multiply by 1 if you want to, but it doesn't change the value, so normally I just skip that step. And then we divide by 0.394. And that's going to give me 231 centimeters. And again, the idea is whatever unit's left is what unit we write over there. Now we could, on the other hand, do it this way. So I could take 91. In this case, I'm multiplying by 2.54. And then I'm dividing by 1, but again, you don't have to do that. And surprise, surprise, it ends up being 231 centimeters again. So it doesn't matter which relation you use between the units, as long as you have the fraction set up correctly, you should end up with the same answer. Now, I was careful in writing the number of digits. Sometimes if you round a little bit, you won't get exactly the same number, but I did it enough so that I was confident they would work out the same. Okay, so again, this fraction is equal to 1. 1 centimeter is the same as 0.394 inches. 2.54 centimeters is the same as 1 inch. This is effectively 1. So 91 inches is the same as 231 centimeters. It looks different, but it's still the same measurement. So really, we haven't changed the value. We've just changed the way it looks. Okay, let's take a look at example 2. All right, Michael Jordan has the longest recorded hang time at 0.92 seconds. What was his hang time in milliseconds? So we're going to just, another quick conversion here. I'm going to show you another visual way to set these up. It's not my personal preference, but a lot of students come into my room and like this technique. So yeah, since it doesn't affect the answer, I don't really care. So we've got 0.92 seconds, and we want to convert to milliseconds. So the other way to visually set this up is they sort of set, I call it the fence post technique. I don't know that that's an official answer. Just to me, it looks like a bunch of fence posts. So we have 0.92 seconds. So we could either say 1 second is the same as 1,000 milliseconds, or 0.001 seconds is the same as 1 millisecond. I'll show you them both just to show that you get the same answer no matter what. In this case, we want seconds on the bottom, milliseconds on the top. We can do it again. 0. Now, and again, in the real world, you would never be doing it twice. That would be a waste of time. But just to show you, if you're worried about, well, how do I know if I'm picking the right one, you don't have to worry about picking the right one. It's going to work out the same no matter what. So I can multiply by 1,000, or I can divide by 1,000th. If you're snappy with your math, you'll know that that is effectively the same thing. So 0.92 times 1,000, 920 milliseconds. And just for giggles, so 0.92 divided by 0.001 also gets you 920 milliseconds. So either way, it's the same answer. You don't have to worry about choosing the wrong fraction, as long as whichever one you've chosen has the correct equivalency and you set it up so that the units cancel out. You can see seconds cancels with seconds, leaves me with milliseconds. Seconds cancel with seconds, leaves me with milliseconds. Okay. Now you can use this technique in multiple steps. And I really encourage you to string these together into one long problem as opposed to a bunch of shorter problems. I do see some students who do one step and then set it up for the next step and then set it up for the next step. I think that takes more time, and it also leaves you open to making mistakes in transcription. So let me show you what I mean by that. All right, example 3. So the world's largest diamond was discovered in South Africa, known as the, I don't know, Cullinan, I'm not sure. And that was 3,106 carats. And we're interested in what its weight is in pounds. So if you happen to have in your house a 3,106 carat diamond, how much is that going to weigh in pounds? So this is an example where you may not know the conversions and you might need to look it up. Now, again, in theory, I could have looked up just carats to pounds and just been done with it, but I just wanted to show you a multi-step solution. So maybe you happen to know that 1 ounce is equal to 142 carats. And if you're an American watching this, you might know that there's 16 ounces in a pound. So when we convert this, we're going to actually do a 2-step process. We're going to convert from carats to ounces, and then from ounces to pounds. And I'll show you how that step works out. Excuse me. In a 2-step solution. All right. So what we're going to do is we're going to start with our initial information. So we've got 3,106 carats. I think carats is abbreviated carat. I don't know. We're going to use that for carats. I apologize if that's not the appropriate abbreviation for carats. Now what I'm interested in doing, and again, I personally prefer the sort of the multiplication visualization technique here as opposed to fence post, but if you like fence post, you do the fence post. You do that. Okay, so looking to see where I want to end up. Sometimes what I'll do is I'll put my goal over here, and pounds is abbreviated LBS. So I want to get carats to cancel out, and I want to end up with pounds. So the first thing, in order to get carats to cancel out, I'm going to need to put carats on the bottom of this. And then I have a relationship between carats and another value, ounces. So I'm going to put ounces on top here. I'm not going to put the numbers in yet. Let's just show you how the units work out. Now, if I want ounces to cancel out, it will have to be on the bottom of this fraction. And then we're going to put pounds on the top. And then that gets us the value that we're interested in. So just setting it up like this, carats cancel with carats, ounces cancel with ounces, pounds is our final answer. So if we look at our units like this first, then we can plug the numbers in. You may want to do it that way. It's an easier way to make sure you've got the fractions flipped correctly so you're not getting confused by the numbers at the same time. So we know that you do now, 1 ounce is 142 carats. And 16 ounces is 1 pound. Okay, and then when we set that up, we multiply by things on top and divide by things on the bottom. So I'm going to enter into my calculator, 3,106. I'll give you a little peek as I'm doing it here. I'm using my cell phone calculator for this one. A little bit of reflection. All right, so 3106 divided by 142 divided by 16. Just do it all in one step. And our answer is 1.37 pounds. So if you had the world's heaviest diamond in your hand, it would be 1.37 pounds. It's a decent sized rock there. Okay, and just for consistency, I probably should have been. So I like to circle my answers when I get to the final stage too. You may like to do that, and that's how we do it. So that's the basic introduction to unit conversion. If we remember back to our original instructions, you have to make sure you set up your fraction equal to 1. The value on the top has to equal the value on the bottom in terms of measurements normally. And every step should get you closer to your goal. Orient to make sure the fraction on the top, orient so that the unit on the top cancels with the unit on the bottom. All right. That should get you through your basic level unit conversions. And if you have some more challenging applications like stacked fractions, say meters per second, or fractions that involve squares or cubes, the next video is going to show you how to tackle those problems. Exact same technique. You don't have to learn anything new. We're just going to apply it in a slightly different way. Okay, well, there you go. That's our introduction to basic unit conversion, aka basic factor label method, aka basic dimensional analysis. Thank you for stopping in for this lesson, and I hope we've made things a little clearer for you with transparent physics.